Um, Before getting into this topic, I would like to give a short description about zTPFGI. zTPFGI is a test management tool which is especially designed for zTPF application, and also it provides a graphical interface to debug the zTPF applications. In zTPFGI, we have various components. One is integrated IDE, DF Explorer, Resource Manager, Performance Analyzer, which is TREX, Connectivity Manager, and Regression Testing System, and Graphical Debugger. In the Graphical Debugger, we have various features for trace. One is trace at source view level, trace at macro and instruction level, set trace for selected programs and macros, asynchronous trace, and finally we have advanced ECB trace option. Advanced ECB trace option includes address stop and trace store. Let me start with address stop. GI will trap the ECB when a specified address is reached during the transaction. It means that we have to specify a list of addresses where we need to trap the ECB, and GI will look for that specified address and stop the ECB whenever a particular address reached during the transaction. And we can have maximum of 8 active address stops at a time, and set up address stop based upon the program name and displacement. We have a list of options in this address stop. One is add, edit, and delete. I can explain you clearly about these options while giving demo. Now I have connected with my test system. This is BP zTPF9. Let me show you how to set address stop. So to set an address stop, we have to select which terminal you have to work. Now I'm selecting ALC1 terminal. So once we select ALC terminal, at the top of ribbon we will have a trace and input tab. Under the trace tab, we have an address stop button. So we have to select this. Once we select this address stop button, a dialog box will open up and it will show you the list of options: add, edit, and delete. Now I'm going to add a address stop. As I mentioned earlier, to set an address stop, we have to specify the program name and then the displacement. To get a program name, we have to specify a source SO name. Now I'm giving SO name. Once we give that SO name, we will have the list of members under this SO. So I have only one member, PRAT. So I have selected PRAT as a member. So now in the displacement, we have to specify a displacement. So we can provide a displacement value in a two form. One is in an integer, and also we can provide it in a hex form. So suppose if we want to provide it in a hex form, we have to prefix the displacement value with 0x. So I'm just giving the value 84. 84 is the displacement which I want to trap the ECB. Now I am saving this. Once we save, you can see a list of added address stop. So I'm adding one more address stop. Save UVA1 as a so, and member name I have selected UVA1. And if you see that drop down, you can see two members, UVA1 and UV24. So now I'm selecting VA1, and the displacement I'm going to give 80. So I'm saying this. So by the way, we can add up to 8 address stop. Select OK to confirm the address stop. Now I'm initiating a transaction from ALC terminal. If you see the ECB graphical window, you can see at the bottom like address, SO name, object name, and function, followed by displacement, operation, and operand. If you see the displacement, this is 84. So which means that during the transaction that 84th address is stopped. So from here onwards, you can continue your trace wherever you want. So during this transaction, another so UVA1 is not hidden. So that's why we have not trapped that ECB. Let me show you how to edit and delete address. Once you select the edit button, you can have the list of members. You can select, you can finish, you can select UVT, and also digit form. So once we give the value in integer, it automatically converted into a display into an hexa form. Now to make the difference, I'm just adding one more address. The list, we have a two address stop at the program PRAT at the displacement 84, and also I have set for E8. Now I'm triggering entry. Now the ECB captures at displacement 84 and also at E8. So by the way, we can continue our tracing. In order to delete the address stop, you can select the address stop and you can select delete button to delete the address stop. Once you do that, that particular row gets deleted. Suppose if you don't want to delete that address stop and you want to make it as a disable, then you can do it by uncheck this button. So once you uncheck that, that color of the icon becomes green, which means that it is in a disable state. So I'm giving OK now. So getting entry from ECB terminal. If you see that, we have captured the ECB at 84. Now the ECB is not captured at E8 displacement because we have disabled that particular address stop. I'm done with address stop. Let me get into a next topic. Trace store. Trace store, GI will trap the ECB when data is stored into a TPF data structure. The TPF data structure includes core address, data level, ECB, and ECB field, file address, and register. So we have also the options for under this trace store. Compare and mask are the two options we have. I can explain clearly with the help of the demo. Let me show you a demo on trace store. Please note that trace store and address stops are mutually exclusive, which means that we can use only one feature at an instant. So now I am going to disable address stop. I'm deleting all the rows. Once we don't have any rows in the address stop feature, which means that we don't have any, which means literally we disable that. So to set a trace store, we have a tab next to address stop, that is trace store.
We have a question here. Can we set address stop like FF.
Yes, we can.
Avinash, does that answer your question? I'm unmuting you. Yes, it's okay. Thank you.
To set it, we have to select which any terminal. So I am selecting ELC terminal. And in the ELC terminal, you will have a tab traced. So here we have trace store button. Once you select the trace route button, you can see a window, dialog box, where you have to select data structure, whichever you want to set a trace. So we have a list of data structure. One is a core address, data level, DECB, ECB field, file address, and register. Now I'm selecting core address. If you know the core address well, you can provide that core address. And about the displacement, from a particular pointer on which displacement you are going to look for. So that's a displacement option. So watch length. So for participant, how many bytes you want me to check? Next data section is data level. So we have a list of data level from D0 to DF. These are predefined one in a ECB. So we can select any of the data levels. So and also meanwhile you can also provide displacement and run the watch length. Next field is DECB. So here we have to specify the DECB name, which is a 16-byte value. We have to provide in this box, and followed by displacement and watch length. Displacement and watch lengths are common for all the data structure. And next one is the ECB field. So if you see the ECB field, we have a various ECB field group. Like these are predefined ECB fields which are available in a ECB. EBW, ECBS, EBX, EBX switches, CE1 FAX, EBC FAX, CU1 CRX, like CU1 CTX, and likewise DTAC and MDBF, and system and user area. So so these are the list of field group, ECB field group we have. And now I'm selecting, so based upon your selection, that ECB field value will get changed. If you see now, it has EBX00, 1, 2. These are the predefined label in ECB. Finally, we have, and I have file address. Suppose in some scenario, during the transaction, we want to tap the ECB whenever that particular file gets updated with some data. So in that case, you can go with the file address, but you have to know the file address, exact file address, to continue with this file address trace. And we have register. So you can select register from R0 to R15. But when you are going with register data structure, please note that using a trace store on register, it will cause a system overhead. That's because, internally we will look for each instruction and check for that particular register whether that particular register gets updated with some value or not. By the way, we are checking. But in case if that particular register is updated with some value, then we will trap the ECB and show to you. So this causes a system overhead at the background. For a demo, I am selecting ECB field, as most of us are aware about ECB fields. I am selecting EBW, and the field is EBD. Yeah, the field I am selecting is EBW00. You can select any value from the list. If you want, you can select from 103 or anywhere. Now I am selecting EBW0 and watch length. Watch length, how many bits I want to look into it. So if you see the ECB field details, if you see the ECB details, displacement in ECB is 0008, which means that EBW00 displacement is 008 in the ECB field, in the ECB. Default watch length is 1. The size of the EBW00 is 1. And maximum watch length is 68 in hex, which means that in integer it is 104, because EBW area is allocated with only 104 bytes. And displacement may be modified. Yes, that is no. Watch length may be modified. Yes, we can modify the watch length which is under the ECB field. And watch area must stay within field. No. So let me show you a demo on how to chart it. Scenario is like I'm going to watch for the EBW area for a 1 byte. As I said previously, trace store and address stops are mutually exclusive, and we can use any one of the features at a time. So as I have not disabled the address stop previously, it gives a warning error to me. So now I am disable all address stop and save. I'm triggering entry now. Now the ECB get captured. If you see the difference, you can see that this is the first byte is the one we are looking for. If you see that particular byte is getting updated with some value. So whenever there is any updation in that particular field, the ECB will be stopped. Okay, let me show you how to use compare data option. So compare data option, whenever there is an update in a EBW area, you want me to stop the ECB. Whenever the particular EBW00 area is updated with a specific value, I want to trap that ECB. In that case, you can select compare data. Now I'm changing the watch length to 8. So watch length and compare data are dynamically generated. So whatever value you are specifying in the watch length will be get updated, and it will be reflected in a compare data. Now I have gave only 8. So if you see over here in the compare data, you can see a 8 byte field. So now I want to check the ECB field with the value A, B, C, D, E, F, G, H, which means that whenever there is a updation in the EBW00 and with A, B, C, D, E, F, G, H value, then stop the ECB. That's my scenario. Now I'm selecting OK. Now I'm specifying entry now. Now ECB stop. If you see the ECB field, you can see that A, B, C, D, E, F, G is updated. So that's why we stop the ECB. Now we trap the ECB from onwards. If you want to continue your trace, you can continue it. Now let me explain you how to use mask value. To give a better understand, let me reduce the watch length value to 1. Suppose if you want to use the mask value, both compare data and mask values are handled and that particular condition satisfied, then we will trap the ECB. For example, and also if you want to trap the ECB in a character level, if you want to compare it, if you want to trap the ECB in a character level, you can select compare data. Suppose if you want to trap the ECB in bitwise manner, you can select mask option. Now I set the mask value as 80, which means that whenever there is any updation in 0th bit, the ECB will be trapped. Now the ECB stopped. If you see the first byte of EBW area, E2 is the value updated, which means that 0th bit is updated with value 1. Let me continue my trace. If you see the next trap, which is C1, which means that 0th bit is turned on. So this is how we can use mask feature. And suppose if you want to see whenever there is a reset or reset in a bit, we can do it by 7F. I'm triggering entry now. If you see the EBW area, you can see the mask value. Now we got trapped because C1 and it is bidder with this value, which means that first bit is, GI is looking for a first bit in a data. So now both the data is turned on. That's why that ECB trapped. I'll show you how to reset it. You need to change the value from 0. Now if you see the EBW area, you can see that 0th bit is updated with value 0, which means that we gave 7 as value in enable, which means 0th bit is 0. So this is how it works. You can continue your trace from onwards. Okay, now I am done with trace to demo. I would like to give some more hints about zTPFGI trace feature. Like we can set a trace option with the help of source trace also and macro trace. I would like to give a precedence about the features. Suppose if you set a source trace, if you also set advanced ECB trace, the precedence will be get for a source trace only, not for a trace store or address stop, which means advanced ECB trace. Meanwhile, in some scenario, you might get into a situation that you want to trap the ECB between some macros. Like you might know that exact displacement where to trap between the macro. Then you can go with the macro trace and also with advanced ECB trace feature. And in the same scenario, if you have a 2 macro and you are going to you want to trap the ECB at the some core value, then you can select macro trace and also with trace store feature.
We appreciate your participation. We do have many more webinars planned on the first Thursday of every month. Please do come back. Thank you all for joining this session. Have a good day.
Thank you.